Taking a look at example 2, dividing using synthetic division. My coefficients are 1, -3, and -18. The number that's going to go inside my box for this process is the opposite of what's inside with this binomial, so a positive 6. I'm going to carry the first number down. Then I'm going to start the multiplication and addition process. 1 times positive 6 is positive 6. I'm going to add straight down, so -3 plus 6 is positive 3. The number underneath the line gets multiplied by the number in the box, so 3 times 6 is 18, positive 18. And then I'm going to add straight down, and that gives me 0. And the last number I always box up because that's the remainder. Notice here I got a remainder of 0, which means that there is no remainder. So I don't actually have to do anything with that number 0. I have a number of 1 and a positive 3. My original degree of my problem was a power of 2. My answer then is going to be 1 less than that, which is going to be a power of 1. So I'm going to end up with a 1x to a power of 1 plus 3. Or you could just write it as x plus 3. All right, I want you to take a look at example 3 and see if you can divide that one on your own. Okay, so example 3. We have x cubed minus 3x plus 5 is being divided into x plus 2. My coefficients are 1, 0, -3, and 5. You might be wondering, where did the 0 come from? Well, remember, it goes x cubed, and then there's no x squared here, so we're going to write it as a 0x squared. Then the x term, then the constant. So hopefully you didn't forget the 0. Taking the opposite of the number that's inside this binomial here would be -2, and that's going to go inside my box. Drawing my line and carrying my first number down. Starting the multiplication process, 1 times -2 is -2. Adding 0 and -2 is -2. -2 times -2 is a positive 4. Adding straight down, and I get a positive 1. 1 times -2 is -2. Adding straight down, I get a positive 3. And again, I put a box around that last number because that's my remainder. Now, the original problem was a degree of 3, so that means this answer is going to be a degree of 2. I'm going to shrink it down a little bit because I wrote kind of big. So my answer is going to be 1x squared minus 2x plus 1 plus my remainder of 3 over the divisor of x plus 2. The second part of this question said, now plug -2 in for the original function. If I plug -2 in for x into this original x cubed minus 3x plus 5, this is what it looks like. I would have -2 cubed minus 3 times -2 plus 5. That ends up giving me 3. Do you notice any place else where we got 3 in our answer? The remainder. So the really fun thing is you can check to see if you did this right or not. Because if you take the number that's in your box and plug it into the function, that is your remainder of your function when you do the division problem. So this is what's called the remainder theorem. That says if you take that value inside the box from your synthetic division process and plug it into the function, it's going to give you your remainder. So you can check your work to see if you're getting the correct remainder or not, to see if you did the problem right. So let's apply this in the very last example problem of the lesson. X cubed minus 2x squared minus 4x plus 9 is being divided by x minus 3. So if I go to set this problem up, I'm going to have 3 in my box because it's the opposite of what's in that binomial. My coefficients are 1, -2, -4, and 9. Before I even start this problem, I'm going to take 3 and plug it into my function and see what my remainder should be when I do the division process. So I'm going to take 3 and plug it in before I actually divide, because I want to see what it should be before I get to the end of the problem. So I'm plugging 3 in for x, just into that first function. When I plug 3 in, I get 6. So what that means is if I do this right with the synthetic division, I should end up with a 6 here, because that's the number I get when I plug 3 into the original problem. So let's see if it works out that way. And actually, I will write this in a different color to remember that this is what we did first. Okay. So starting off, 1 times 3 is 1. Adding straight down, and I get negative 1. Negative 1 times 3 is negative 3. Adding straight down, and I get negative 7. Uh-oh, I did something wrong. Let's see here. Oh, I know what I did wrong. And I know I did something wrong because I have my key next to me and the numbers weren't lining up right. So I apologize. What I did wrong is 1 times 3 is 3. So that should be a positive 3 there. Oops. Negative 2 plus 3 is a positive 1. 1 times 3 is 3. Negative 4 plus 3 is negative 1. Negative 1 times 3 is negative 3. And 9 plus a negative 3 is 6. So we know we did it right. The original degree was a 3. Reduce that by 1 means I'm going to end up with a 1x squared plus 1x minus 1 plus the remainder of 6 over x minus 3. And if you wanted to write this as x squared plus x minus 1 plus the 6 over x minus 3, that means the exact same thing. All right, so that wraps up synthetic division, and now you're good to work on the 3.3b assignment for synthetic division.